Hi everyone, I am so sorry to be missing our first class together. I'm very much looking forward to meeting you all properly tomorrow, hopefully, as long as my PCR test comes back negative, because I do have a sore throat. So this unit is going to be all about the Earth's resources. We're going to do the rock cycle and the water cycle, so we'll focus on those two resources, but we'll be looking at how people manage water, how the rock cycle actually works, different types of rocks that you can find, and we're going to start off looking at what are the Earth's resources. So what are the resources that humans need to survive? I want you to pause this video and think about that for a bit. Hopefully you've come up with some ideas of what resources the humanity needs to survive, and we'll see in a second if you got some of the ones that I thought of. The other question I want you to think is, what would it be like to live in a post-scarcity society? Now, post-scarcity just means nothing is scarce, so you have like an unlimited supply of resources. So what would it be like to live in a society where you had unlimited resources? You have unlimited food, you have unlimited electricity. What would that be like, and how would that change our lives? I want you to ponder this for a second, pause the video, think about it, and then we'll go on. Okay, so now I hope you had a bit of a think about what it would take, what life would be like if we had unlimited resources. Now we're going to talk a little bit about what resources we actually need, how we obtain some of these resources. Specifically, we're looking at water, soil, and energy. And then we're going to look at the steps in the mining process, how it actually works, and look at some of those harsh realities of the environmental impacts of mining. You'll also watch a little video on the circular economy that I've posted on ManageBack as well. So, here are the main resources that I thought of. Hopefully most people thought of water, there's soil, timber. These are all the sorts of things we mine from the ground. There are obviously a lot more than these. There's salt, iron, bauxite has aluminium in it. Helium and copper. These are all the sorts of things we mine. And finally, we've got lots of energy sources. So they're into like three classes. These are sort of like our natural resources. These are our mined resources, and these are our energy resources. And we've got lots of different energy resources here that we will go through in one of the other lessons, actually not today. Today, we're just going to go through our main energy source. So first we'll cover water. Where does your water come from? Do you actually know where we get our water from? If you're watching this as a class, you can pause it and discuss as a class where you think water comes from. If you're watching this individually, I want you to really think about this. Where do you think your water comes from? Well, of Earth's water, you may have heard of this before, only about 2.5% of it is fresh. Yes, we can use the oceans in a process called desalination, which I'll talk about in a second, but most of it we have to use the fresh water. Of this 2.5%, only about 1% of this is surface water. So this 2.5% has been expanded, right, to show you of that 2.5%, most of it's actually trapped in our glaciers and ice caps. We can't really get to that. Transporting water long distances, it's a very heavy substance. It's not something that's financially viable. Groundwater is something that some countries use, but it takes a really long time to be replenished. You actually need a lot of rainfall, and it has to seep into the ground, which most rainfall doesn't actually seep down into the ground. You need very heavy, very sustained rainfall for groundwater to be replenished. And so groundwater will run out if you use too much of it. So most of what we use is actually the surface fresh water. And of that 1% of the 2.5%, so we're getting down to like fractions of it, 1% here, you can split this up, and most of this is actually in ground ice permafrost. So you can see that there's a lot of ice or water trapped as ice in cold areas of the planet. Only about 20% of it is in lakes. And I don't know what you possibly thought of before when I asked you where the Earth's water is that we get, that we use, but we basically only use lakes. And actually, we mostly only use man-made lakes, so dams. That's pretty much where we get all our water. Sometimes there are natural lakes, but generally we dam up one wall, downriver wall of this area to make the lake bigger and bigger and bigger so that it can hold enough water for a population centre. Before dams, civilization wasn't really possible because you couldn't really have a large population if you didn't have a large water supply. So that's where we get most of our water from. This diagram shows the aquifers in Australia. This is the groundwater. So aquifers are where groundwater exists. It's one word. I'm putting it in two words because it's I can't fit it there, but it's actually one word. Groundwater exists within the rock underground. So rock is that is porous. You can see it says porous is the best for aquifers because it can hold a lot of water in those little holes inside the rock. Porous means there's holes inside it. So porous rock means that it can trap lots of water, and this section here is called the Great Artesian Basin, I believe, and that has really good water quality and good water flow. In Melbourne, looks like we don't have great aquifers around here, but we do have a lot of lakes around Victoria, so we don't really need the groundwater. But the fact that this water exists inside of Australia, that's how Indigenous people have survived for, millennia, many, many thousands of years, possibly 80,000 years, they think now. Even like at the most desert centre parts of Australia, there's still water to be found, and they could actually spot where these water reserves would be looking at the plants and the animals at the surface, and they'd be able to track down and dig down for the water. Desalination is another way that we can get water from the ocean. Obviously, the advantage is that there's a huge supply of it, but we also have the byproduct of salt that we have to deal with. And we also need a lot of electricity. It actually takes a lot of electricity to run desalination plants. So desalination just means taking the salt out of the water. And it's done by this process called reverse osmosis. You probably don't know what osmosis is. So basically osmosis is just salt's tendency to soak up water. I don't know if you've ever lived in a humid climate, but I lived in Queensland for a while, and the salt shaker would get clogged within a matter of weeks of buying it because the water would get in the air because it was so humid, would get soaked up by the salt, and then it would clog it. It wouldn't fall out anymore. It was really annoying. But basically osmosis is this tendency for salt to absorb water, and sugar actually does the same thing. So when you do reverse osmosis, you have to get the salt to let go of the water. And the way that they do this is they actually push the water through something called a semi-permeable membrane. And this membrane, it lets the water particles through, but it doesn't let the salt particles through and other contaminants. You can see they've been blocked by this barrier. And then at the other end, you get fresh water. And usually there's a whole series of these membranes in order to get it to the state where it's nice, pure, clean water. Very clever process. You can see that if right now our dam levels are at about 75%, or they were about a year ago. I think they're probably pretty similar now. So the water level now is at 75%, but if we hadn't got the desalination plant, we would be at about 59%. And you can't really get below about 30% in dam levels, or else your water quality starts to get really bad. So we actually, when we get to 40%, we actually get pretty extreme water restrictions in Victoria to stop that happening, because we want high quality water, and we do have very high quality water in Melbourne. You also need to treat it more, put extra chlorine and things like that if it gets too low. So I am going very quickly. Make sure you pause and take notes where you need to. Okay, how does soil form? It's a pretty interesting process, actually. I'd like you to have a guess of how long soil takes to form. If you're watching this as a class, pause the video. If not, just pause the video and talk to someone next to you and say, how long do you reckon soil takes to form? Because it takes a really, really long time. Basically what happens is lichen, you might have seen this stuff, it's called lichen, growing on rocks. That's the first stuff that ever colonized land, or something similar to it, an ancient version of it. Originally, the planet was just rock. There was no soil. Originally it was molten rock. It was just as gas and solid particles, dust came together in the early solar system. The heat of everything falling together to form a planet melts everything. So everything's just rock and water. There were some oceans pretty early on in the Earth's development. So the whole planet was just rock. And it took for life to evolve in the oceans before things came out of the oceans. And then once they were out of the oceans, things could start to colonize this rock. And lichen would, or something similar to lichen, would have been the first thing to do this. And it would have had to, the current day lichen uses acid to break down the minerals in the rocks. Rocks are made of minerals. We'll talk about that more in a future lesson as well. The lichen breaks it down with acid. It makes little cracks in the rock. And then what happens is the water flows into these cracks. And if you have, so you've got cracks forming in rocks, and then the water flows in to the rocks when it rains, right? You get rain. And then the water sits in there. And what happens when it freezes over? Ice expands when it cools, doesn't it? If you put a bottle of something in the freezer for too long to cool it down, it explodes. It's not very fun. I did that a couple months ago. The water actually expands and it will actually crack the rock. The rock will get a crack through it and it will break it apart. So it's a combination of weather processes and things like lichen feeding off the rock itself, breaking it down, that take a very long time to create this humus, which is essentially soil. It's dead, decaying material, plant life. So it's actually dead biological life mixed with the minerals in the rocks that creates this soil. And it takes, for about 1 centimetre to form, takes about 500 years. So if you think of a metre of soil, you get about a metre of good quality topsoil in most places. That's taken 500 times 100 years. 400 centimetres would be 50,000 years for that to form. So it's a very long process, and they actually think we're losing about 20 football fields of soil every day. And that is because farms leave their fields blank, without plants. If you drive through the country, you often see fields that are empty. When they're left empty like that, the erosion that causes, the wind blows away the soil, the rain washes it away into rivers. The erosion that causes means that we're losing lots of soil far quicker than it's actually produced. So eventually, if we keep letting it happen, we will run out of soil too, but that's a bit further down the track, I hope, than some of our other pressing problems. The next resource we're going to look at is energy. Sorry, this is a bit of a long lesson. So where does your power come from? Now, you might not know this, but pretty much all of your power in your home, your electricity, comes from coal. A coal-fired power station, and I'll talk about how that works in a second. But coal, the way it's formed is it's formed from swampy ancient forests. It has to be really wet. And when the decaying plant life drops down, it doesn't actually decay. It stays sitting under the water. All right, so because it stays sitting under the water, all of that carbon that's in the life, carbon is very important. All of the carbon, I didn't do that very neatly. All of the carbon trapped in the ground will get changed by heat and pressure. So it's actually a chemical change, which you may or may not know about yet, but that's right. We'll do chemistry later in the year. But basically the heat and pressure of rock layers on top cause it to change from peat to brown coal and then to black coal. Black coal is what we like because that burns cleaner, so it's a little bit better for the environment. Brown coal, we still mine lots of that as well. It's just doesn't burn as well, burn as cleanly as black coal. So it's about how long it's and how much heat and pressure it's been under and how long it has been in the ground. So why does it get exerted all this heat and pressure? Well, basically the layers of sediment over time build up on top of that. This is like the old ancient rainforest right down the bottom. This is like where the old ancient rainforest is. And that is getting crushed by all the layers on top. And as it goes down into the planet, if you go down into the planet, it actually gets hotter and hotter and hotter the further down you get into the Earth's crust. So that heat actually converts it into oil and gas and coal. All of the different fossil fuels all can be found in these deposits. This one shows oil, but all of those things, coal, I'll write it down, coal, oil and gas, they're the main fossil fuels. They're all found there. And what do? Well, we take it to a power station where we burn it. Once it is burnt, that heat is passed through water. The water is then used to create steam that spins a turbine like any windmill turbine. And then the turbine will then be attached to a generator. Generators have magnets inside them, lots of little magnets, and they spin, and that pushes the electric current through the electrical wires. So that's the basics of how a coal-fired power station works, and pretty much all of the power in Victoria is created that way, like over 90%, I'm sure. If you buy green power at home, you can encourage them to build wind farms and solar farms, which are great, and at this stage they've become cheaper than coal. Even though they charge you more in your bill, it's because they're constructing new plants in order to do it. In terms of the cost of producing the energy, wind is now the cheapest energy source on the planet. So they're not really building coal-fired power stations anymore, even though the government likes to support coal in Australia for some reason, probably because it's one of our major exports. We have a lot of natural coal reserves in Australia, so we like to promote it as something for other countries to buy from us. But actually, they're not really being built anymore. They're being shut down because end users are putting solar panels on their roof, so our power demands have gone down, and people don't want to use coal anymore, and it's not economically viable anymore. So now we're going to go on to mining, and that's kind of our last topic pretty much for today. And you don't really need to know the details too much of this. You basically just need to know the steps in the mining process. So when they're going to do a mine to find one of these metal resources usually, or something similar, we also mine lithium for batteries. So all the car batteries these days and all your device batteries all use lithium. So that's one of the things that's mined as well. But mostly it's a type of metal that we're looking for. So what geologists do is they construct these surveys where they look at the different types of rock on the surface, and from that they can actually figure out how those different types of rock were created, and that gives you some hint of what types of minerals are likely in those areas. Then what they do is they drill down into the earth, and they get like a core, and then they pull that core back up, and it has all of the different rocks in the layers in the order of which you find them in the ground. So they do this in many, many different locations, and they build up like a 3-dimensional depth image. You get a cross section of like this is here and this is here and this is here across a kilometers of area. Then if they think that there might be something good there, they'll look at the type of ore that they can extract, the quality of that ore. There's all different types of ores. Ores basically have whatever you want. Maybe it's iron and lots of other things as well. Other minerals, and you need to look at the cost effectiveness of whether that is something that you can extract, and it's the cost of the metal is high enough to justify the extraction, because a lot of metals they aren't worth very much, and so if it's a really hard to extract metal from that type of ore, they won't bother building the construction plant there, even though you could get the metal from it if you wanted to. But it actually fluctuates where is a viable location depending on the market values. Then they'll plan and design the mine. And basically it's just a matter of figuring out what type of mine they're going to build, whether it's open cut or underground mines. They have to design the processing facility, which is usually on site. So they usually process it from ore right into the metal on site. And then you have to clear the land to construct the mine. So planning and design, and then construction of the mine itself. Depending on where it is, this could be clearing forest, clearing ocean areas, building ports for your ships to come. You can see all the ships lining up out here to come to the port. And then you actually do the mining process, and that's only going to last for so long. Like a mine might have a lifespan of 30 years, 50 years, or 100 years, depending on how much is in that location. It could be an underground mine or a surface mine. It's two different styles of mining. Once you've finished doing the mining, you need to process your ore. So I said before, the ore, spelled O-R-E, is made of whatever you're trying to get out, plus other things. It's usually crushed and then mixed with chemicals, water, air, all sorts of different things, not at one time, but in different sequences. Sometimes you might have 50 steps to get your metal out. So that's why you can imagine it can be quite expensive. You need different chemicals, different machinery in order to do it. In this case, it's copper. The bubbles are filtered and skimmed off the surface to get the copper concentrate. Then you do a smelter is where they melt metals. So in the case of copper, they will melt it, and then they use a process called electrolysis to get the copper out. So they actually run electricity through a copper sulfate solution. So it's got water and the metals in it. And on the end where you've got one of your metal conductors, the copper will actually congeal around that, and that's how you get the copper out. After the mine has finished its lifespan of collecting ore and processing it, it is supposed to be closed and rehabilitated. They should look like this after rehabilitation, or sometimes they fill them with water if you've been mining something that's not too toxic. But most of the time, they're abandoned. There have been more than 60,000 mines abandoned across Australia, according to a report that raises concerns about how land rehabilitation is managed. I knew someone who worked for a company, a geological survey company, that gave recommendations to the government and to these companies on how they needed to be rehabilitated. And he said that it was totally corrupt. He tried to do recommendations for rehabilitation, and the company basically said, you can't tell them that they have to do that, or they'll fire us and they'll get someone else to do it, because it's run by private companies, not by the government. And so a lot of them don't actually get rehabilitated. So we have the ongoing pollution to deal with for the rest of the lifespan of our country if we don't get them to do this. And my friend quit his job and is now a science teacher as well. So some of the environmental impacts of mines are you can have tainted groundwater. Obviously, if they dig down, they're getting into the layers of the groundwater. We talked about aquifers before. So it can do it for thousands of kilometres because those aquifers run through thousands of kilometres. So if you put some chemical into the ground, it can run for a very long distance. There's a lot of cancer risk to miners and surrounding communities. Pretty much any type of mine will have an increased cancer risk in the area. You have to destroy the habitat to actually build the mine. And there are spills from the processing plants. Pretty much in every mine, it just happens that things get spilled into the environment somehow. And they also use a lot of fossil fuels. The big trucks and machinery that they use to move the ore use a lot of fossil fuels, so very bad for climate change. And those fossil fuels are often paid for by the Australian government through subsidies. So you, with your taxes, or your parents with their taxes, get to pay for the mining companies to use their machinery. There's also lots of impacts, like the Adani coal mine could kill off the Great Barrier Reef, because their ports are right where the Great Barrier Reef is, and there'll be lots of ships coming through there carrying coal. You have lots of land clearing in the Amazon. This is ruining their rainfall. You can see the line there where this is one huge open cut mine where they haven't bothered to dig down. They've just done the cheap and easy thing, which is spread out. And then you've got beautiful pristine rainforest, which is slowly being destroyed. You also have, this is the Amazon River, you also have erosion from these mines that contaminates and pollutes the rivers, so all the fish and wildlife that lives in those rivers dies. In Utah, there are a group of citizens that found that the pollution in the air from an open cut mine, the dust from the mine, this is the mine there, was equivalent to smoking 20 cigarettes a day. The dust was getting into the bloodstream, causing respiratory system damage, so damage to the breathing system, pulmonary effects, damage to the lungs, pulmonary refers to lungs, and potentially even premature death. So you have a legal right to clean air and water. That's one of the United Nations human rights, and your country has to provide that to you, and if they don't, you can sue them. So is humanity sustainable in the long term? That is the question that we have to ask, is how sustainable are we? And I don't know if you've heard this, but if everyone in the world lived like we do in Australia, it would take 4.5 Earths to feed and give them the phones and computers that they require to go about their daily life. So probably not sustainable in the way that we live here. You'll also need to watch this video on the circular economy before doing the end of lesson quiz. And I can't wait to see you all tomorrow. I hope after my test comes back negative. See ya.